Hi everyone! In this video we are going to go over the graphs of some other trig functions. We're going to go carefully through the graph of secant of x, and then I'll show you some tricks that will allow us to graph cosecant of x a little bit more quickly. So let's get started. Secant of x, the definition of that function, as you know, is 1 over cosine of x. So this is a fraction, 1 over cosine of x. As we plug in different x values, this denominator is going to change. So we can think about secant of x in terms of cosine of x. Let's say that cosine of x is very, very small. So if cosine of x is like 0.001. then secant of x is going to be very, very big. So just some little notes. 1 is when cosine is small, secant is big. And vice versa, when cosine is big, secant is small. What else might you notice? Well, what happens if cosine of x is 0? Then secant of x is 1 over 0. We'd be dividing by 0. That's undefined. So if cos of x equals 0, then secant of x has an asymptote, which you'll remember from our rational functions unit. When we have a 0 in the denominator, that makes an asymptote in the graph. So we're going to use these properties, but first let's just plot some points for secant of x. Our strategy is first going to be to graph cosine of x. So let's go ahead and do that. So cosine, we know, has the tulip shape, and at 0, cosine of x is 1. What else do we know? At pi over 2, we're going through 0. At pi, we're at -1, and 3 pi over 2, we're at 0, and 2 pi, we're at the end of our tulip. So here's what a single cycle looks like. Some points on this, well, we have pi over 4, comma, root 2 over 2, because cosine of pi over 4 is root 2 over 2. We could go to the other side, and we get symmetry. So we would also have at negative pi over 4, the value of cosine is also root 2 over 2. Okay, so this one is the graph of cosine of x. Now we'll try to come up with some points on the graph of secant of x. So if we try to see what, let's say, secant of 0 is, that's going to be the same as 1 over cosine of 0. Cosine of 0 is 1, so this is 1 over 1, which tells us that 0, comma 1 is on the graph of secant. So that point. What if we plug in pi over 4? Well, that's the same as doing 1 divided by cosine of pi over 4, which is like 1 over, well, cosine of pi over 4 is root 2 over 2. So instead of having root 2 over 2 in the denominator, we're dividing by it. This number is approximately 1.412. So actually, we'd be up here. Let's do a couple more. So secant of, let's try pi over 3. That's the same as 1 over cosine of pi over 3. Cosine of pi over 3 is 1/2. So this is like 1 over 1/2. Which is 2. So at pi over 3, we're at about 2. Oops, pi over 3 is there. And finally, if we do secant of pi over 2, that's like 1 over cosine of pi over 2, but cosine of pi over 2 is 0. So that's where our asymptote is. So you'll notice that cosine is 0 also at 3 pi over 2. So we'd end up with another asymptote there. Cosine of 0 is cosine of negative pi over 2 is a 0, so that gives us an asymptote of secant. We get an asymptote of secant at negative 3 pi over 2. If we start to connect these up, we'll notice that it connects up like this. It has to stay left of the dotted line because that's an asymptote. And you can imagine that on this side, it's going to go this way because I'm basically taking this curve and I'm flipping it because when the values of cosine get smaller, the values of secant get bigger. So everything flips. So in this little section, I've got a downward U. On the last one, I've got an upward U. Here I'd have a downward U. And here I'd have an upward U. So the tricks here are basically, if I want to graph secant of x, my first step is to graph cosine of x. My second step is to mark asymptotes wherever cos of x equals 0. So that means put in these dotted lines at the zeros of cosine of x. And then 3, I make u's by flipping maximum points to minimum points. So those are sort of the tricks, but you could always come up with the graph just by plotting lots of points like we were doing down here. So let's use these little tricks to come up with the graph of cosecant. Cosecant of x is 1 over sine of x. So the first thing I'm going to do is graph sine. Okay, so let's make 1 there and negative 1 there. Sine it starts at 0, 0. It hits its maximum at pi over 2, comes back through 0 at pi, hits a minimum at 3 pi over 2, and gets back to 0 at 2 pi. So we have our nice sine curve, which looks something like this. Keeps on going, and it's symmetric on the other side. Well, symmetric through the origin on the other side. So there's our graph of sine. Now our step 2 is, well, whenever sine of x is 0, so whenever we have these x-intercepts, that's going to make cosecant equal to 1 over 0. So I have to mark asymptotes for cosecant at the zeros of sine. So here's a 0 of sine, so I put my dotted line in there. Here's another 0, so I put my dotted line there. Have another asymptote here, 1 here, and 1 here. Now my final step is to make the u's. When sine is big, cosecant is small. So this max becomes a min of cosecant. It's a u, and it has to fit between the asymptotes. So that's one part of my curve. I've got another one here. I've got another one here. I've got another one here. And these u's will keep going because sine keeps going. So let's do one final example, a trickier one. Let's say that I want to graph 2 cosecant x plus pi over 4. So in order to do this, I want to use those same strategies, so cosecant is 1 over sine. But I can't just use 1 over sine because I have this x plus 4 and this 2. But what I can do is graph 2 sine x plus pi over 4. And then I'll do the same thing I did before. I'll draw in my asymptotes and I'll make my u's by turning maxes to mins and mins to maxes. So let's work on this. Sine of x plus 4 is a shift to the left by, or x plus pi over 4 is a shift to the left by pi over 4, which means my cycle is going to start at negative pi over 4, and it's going to end pi over 4 away from 2 pi. And the center of it, instead of being at pi, will be at 3 pi over 4. Okay, so these are going to be my zeros. My maximum is going to, instead of being at pi over 2, it will be pi over 4 to the left of that. So this is going to be a max. The min is going to be shifted by pi over 4. And now since I've multiplied by 2, my max is going to be at 2 rather than at 1. My min is going to be at negative 2 rather than at 1. So my graph is going to look something like this. And it will continue similarly. So let's just focus on this portion. We know the graph keeps on going, but we can get enough of the picture just from this piece. So now my step 2 is to mark the asymptotes like before. So I have an asymptote wherever this graph hits a 0, wherever the graph of sine hits a 0. So here's an asymptote, here's an asymptote, and here's an asymptote. So I know that my u's are going to have to fit in between these dotted lines. And I'll draw them in now. This was a maximum for 2 sine x plus pi over 4, so it will be a minimum of 2 cosecant. So it becomes a u facing up. This point was a minimum of the blue graph, 2 sine of x plus pi over 4, so will be a maximum of cosecant. So I have my u facing down. And these u's would continue in that form. So I hope that this video was illuminating. And if you'd like to see a summary of just what the graphs of these generally look like, I'll post a PDF that just has some pictures. So good luck and watch this video as many times as you need to.